asks, is calibrating KV beams different than MV beams? What detectors do you use? And describe the equation to the right. So calibrating KV beams is in fact different than MV beams, mainly because KV beams are a bit more finicky. They tend to show very strong energy dependence for the detectors in these KV ranges. And in fact, because of that, we really can only get typically around 4% accuracy, which normally TG51, obviously we don't like that, but because these energy dependence of the detectors and just the nature of the KV beams themselves, that's normally what we see in terms of uncertainties. So typically for KVs, we're looking at 40 to 300 kVp. And what detectors do we use? So that is solely dependent on the energy that we are using and of our beam. So if we have something that is less than 40 kVp, it's necessary that we use a plane parallel chamber, also called parallel plate chamber, whichever you'd prefer to call it. So we have to use that. Now, if we have something that goes from, let's say, 40 to 300 kVp, then we can use a farmer chamber, which we are obviously much more familiar with. So the 40 to 100 kVp is really like our superficial X-rays, and we take these measurements often in air. And for 100 to 300 kVp, we are normally measuring in millimeters of copper for the half value layer. We can use a farmer chamber, and that you can do in air or water. So if you have less than 40, you really need to do air. Less than 300 potentially you could do in water. So that brings us to our third question here. What is this equation to the right? So if you see this in an exam, this P stem air should give it away right off the bat. This is a measurement in air. Also, we have our absorption coefficients. It's also in air. Okay, so we're taking measurements in air, and we have this dW, that's dose in water, measured in air. So this specific equation is used for 40 to 100 kVp, and if you haven't noticed, this is directly from TG61, which you certainly need to know that task group. I know KV beams aren't as common, but they expect us to know it, and you never know, your clinic may, or you go to a clinic and they do have it. So let's talk about setup. So we mentioned 40 to 100 kVp. We're going to do a 2 centimeter depth. And, I'm sorry, going back, I got carried away. It's very easy to think about there's two equations in TG61. The other one is in water. I'm thinking about water. So go back that. No depth. We have no depth here. So going to M is just our readings, our measurements, corrected. NK here. So this NK, it's called the air-Kerma calibration factor. The BW is something that should also help clue you into, hey, this is different than the TG61 for water, because this has to assume it's the backscatter factor, because that accounts for the buildup in the water compared to air. We're taking these measurements in water or air, so there is no buildup. There's no backscatter because it's air. But in water, we do have backscatter. We do have buildup. So we need a factor to accommodate that. So that's why that BW is there. Very important. That will clue you in to which one these are talking about. And then the P stem are the stem effects, that these change with the field size. So that's dependent on field size. Backscatter factor, you will just look that up. It's based on SSD and your half value layer, which is just simply how you are going to define the energy of your beam. And like we mentioned, a P stem changes with the field size. The energy attenuation ratio, you can just look up using the half value layer there. So that is TG61 for in air. There's another for water we will get to. Hopefully this gives you a little more background on KV beams and how we measure them. If you have any questions, please comment below. I'll be happy to help. Best of luck studying.